Let's begin. Today's December 30th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 7, 9, 18, 19, 21, and 22. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our last digit, the circle digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will take a look at our 3 digits, triangle, square, and circle, add them together, and the Turing Machine will let us know what the sum total is. Is it an even quantity or an odd quantity? Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E, again, will take a look at our 3-digit solution, except this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 2 cases. One where there's a pair, as in the example 131, or alternatively, there are no pairs, but there are 2 scenarios. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F, again, we'll take a look at our 3-digit solution from triangle to square to circle, but this time it'll let us know a little bit about the ordering of the digits. Should the digits appear in an ascending order, meaning that they're increasing, as in the example 135, could they be in a descending order, basically decreasing, as in the example 421, or alternatively, there is no order? So let's take a look at the example 231. Notice it goes from 2 to 3, it increases, and then goes from 3 to 1, then decreases. Of course, you could have a 3-digit code that decreases and increases, but basically it's that shift from one direction to the other that defines a 3-digit code as having no order. Now, there is an alternative possibility that we've seen in previous puzzles, and that's when you have consecutive equal digits. So as an example, let's look back at criteria card B, this code 331. That exhibits no order. It does have consecutive, meaning that they're next to each other, equal digits. The 3s are equal. And the reason I say that examples like 331 have no order is that when you go from the first 3 to the second 3, there is no change. It neither increases nor decreases. And that's why I state that consecutive equal digits exhibit no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card A. Okay, so the Turing Machine approves of my choice in circle. I did pick an even 4, and the Turing Machine confirms it. So yes, we can state that circle is definitely an even digit, and we'll put that note in section A. And we'll say that circle is an even digit. And since it is even, let's go ahead and cross out the 3 odds. So the next thing I think I'd like to test is criteria card C. Okay, so the Turing Machine does not approve of my proposal. Notice that in criteria card C, we are adding up the 3 digits, Well, let's go ahead and do that with my proposal. So 3 plus 1 is 4. 4 plus 4 is 8. 8 is an even quantity, but the Turing Machine does not agree with that. So that means that the sum of the 3 digits actually should be odd. So let's write that up in our notes in section C. And we'll say that triangle plus square plus circle must be odd. And what can we say about that? Well, remember in criteria card A, we established that a circle must be even. Well, if we want the overall sum to become odd, that means that let's see, let me actually think about that. If we have an even digit, we want it to be odd. That means that I believe one or the other among triangle and square, one of them has to be even. And so the reason for that is that if I have an even, and again, I don't know where, triangle or square, added to the even that we have in circle, so that sum thus far would be even, but then that other digit must be odd. So that way that sum total is odd. So so we're looking at 2 evens and an odd. And again, one or the other is in triangle and square, one is even, the other is odd. Well, so I think the next thing I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my choice. I did pick 3 for triangle, 1 for square. That sum is 4. 4 is less than 6, but the Turing Machine does not agree with that. So that means that the sum of the first 2 digits is either equal to 6 or greater than 6. So let's go ahead and type that up in our notes in section D. And so that is that triangle plus square should be either equal to or be greater than 6. Okay, since triangle and square are both different, meaning one's even, one's odd, I know that the sum of the two could not be 6. So actually, because the sum of that would be odd, it can't be equal to 6, and we just established that it's not less than 6. So in fact, we're going to be able to deduce that the sum has to be greater than 6. So that's just based on deduction, and we just, we're just fortunate that that's how it played out, knowing that triangle and square, so essential that one's even, one's odd, helped us to deduce that the sum must be greater than 6. So if we want to assure ourselves that the sum is greater than 6, then neither triangle nor square can be 1s, because even when you add 1 to the largest of 5, that's just barely 6. And so it's not going to get any bigger than that. So I couldn't add 1 to anything to assure ourselves that the sum would be greater than 6. Okay. Anything else? Yeah, I think the only thing we can say is obviously it's not going to be 2 small digits like 2 and 3, because of course those are less than 6. So if there's going to be a 2, it's got to be added to a 5, right? And so, but starting with 3 and above, all those combinations will work. 3 and 4, 3 and 5, etc. So we can't cross out the 2 because it could still be added to 5, but we'll just keep that in mind going forward and how we consider our 3 digits. Let's see, anything else? Again, we do have 1 odd, 1 even. I think that's about it. Well, this does conclude round one. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So let's see. So we did not test criteria card B, inquiring how many threes there are. And we did not test criteria card E, establishing whether we have a pair or not. And we didn't test criteria card F, figuring out the ordering of our 3-digit solution. Well, if you recall from previous videos, you'll recall how we use criteria card E and F to play, how they play against each other, and how we can deduce them both. So that's why I reserved these two to the second round, because I did remember how they played against each other. There's no need to test them in round one because we are going to be able to deduce them. So this is how the argument goes. So both ascending and descending, although one goes in one direction and the other, essentially they behave the same. They're either increasing uniquely, meaning that there shouldn't be any consecutive or equal digits, and so they are unique in their ascension and descension. So that means that if you were to have an ascending solution or a descending solution, you would know that there would be no pairs. There would be no pairs in that listing of ascending codes and descending codes. But because you would know that there are no pairs, that would make criteria card E irrelevant. So for that fact, it must be that the solution, we're going to state that we're going to deduce that the solution has no order. Okay. And in a similar way, we're going to state, what if you had a pair of digits? So if you had a pair of digits, notice in the example 131, it increases and decreases. That's one of the ways I defined a code to have no order. So if you had a pair, we would know that it would have no order, making this card irrelevant. Now, there are other kind of pairs, as I stated in the top of the video. When you have the pairs at the beginning or at the end, those also exhibit no order because there is no change, remember? So if you ever have a pair in any configuration, we would know that there would be no order. So in fact, the solution should have no pairs. So we're going to deduce that the solution has no pairs. Okay. So let's see. So our two possibilities are either they're all distinct or all the same. Of course, since we already established that triangle is either between triangle and square, you have an odd and an even. They can't be the same digit, so they are going to be all distinct. So we're looking for a 3-digit code that's all distinct, where the sum is greater than 6, and we are looking again for two evens, and criteria card B lets us know if there's a 3 or not. So at this point, because we only have one odd, either the 3 is there or it's a 5. So we're looking at combinations of no order, 2 evens, and either a 3 or a 5. So we definitely know we have a 2 and a 4, and maybe a 3 or a 5. And so let's see. Can we list them out? So remember, we have no order. So could it be 2? And remember, it's even odd. So this would be 2, 3, 4. No, it couldn't be 2, 3, 4 because that's increasing. but it could be 2, 5, 4. So let's list them out. And so 2, 3, 4 failed. 2, 5, 4 on the other hand is valid. So 2, 5, 4. And that would be the only possibility for triangle 2. Okay. Let's now use 4. Let's just do the evens first. And so it would be 4. It wouldn't be 4, 3, 2. It would be 4, 5, 2. So 4, 5, 2. And I believe that would be the only solution with 4. Okay. So those are triangles even. And, well, I guess based on this, neither one has a 3. So the 3 cannot go in square. It would seem so. So let's now do 3. What would that look like? So it could be 3, 2, 4. But 3, 2, 4 is actually less than 6. So let's actually cross it out. That would not work. So it wouldn't, but 3, 4, 2 could work. So 3, 4, 2 could work. What else? And I believe that would be it for triangle 3. What about 5? So that would be 5, 2, 4. Because 5, 4, 2 would be descending. Okay, so it looks like we only have one solution that has a 3 in it. Perhaps maybe the ones that have 5 are all ambiguous. So those all would have not a 3, right? 0 3s. All of them do end in an even. They all have an odd sum. What else? The sum of the first two are all greater than 6. There are no pairs, and they all have no order. So it looks like the only possibility is if you do have a single 3. So it looks like our answer is going to be 3, 4, 2. So here, I think I'm going to say we're going to deduce the solution has a single 3. And it would have to go in the first spot because if square is 3, then you'd only have descending or ascending. So yeah, it looks like our solution is 3, 4, 2. So let's type that up. Okay, well, we sort of reviewed it all, so let's actually verify that 3, 4, 2 is correct. So 3, 4, 2. Fantastic. Well, how did we do versus a Turing machine? Well, it is a 6 criteria card puzzle, and we did it in just 3, just one round. Incredible. So we did A, C, D, and we outright deduced all of the other 3 remaining. How incredible is that? So let's go type that up. That's A, C, D, and A was the only correct one. A, C, D. And in one round, no less. Okay, wow, incredible. We beat the Turing machine by 3 questions. Well, no doubt, obviously, again, going back to criteria cards E and F, that was a huge, huge advantage to be able to deduce that. And then And then we just, did some process of elimination to establish that the remaining, it looked like 3 at the end because one was not the right sum, but the other 3 were ambiguous. You could not distinguish them based on the criteria cards and what properties they exhibited. So yeah, a little bit of process of elimination came up with the correct solution. Well, how about you? How did you solve? Did you recall criteria cards E and F and that we were able to outright deduce and take advantage of that? Or did you choose a different set of criteria cards but still have something to share, something that you found interesting about how you solved it? Please add that to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.